Dear students, welcome to my channel. I am Krishna, your BBS trainer in Excel. Today I am explaining about entering the formulas in Excel sheet and how to bifurcate the dia-wise quantities. So I am taking for an example of one of our project drawing details. I am showing you in the AutoCAD. Here this is an 100 unit apartment project having a complete GFC drawings. In this I am taking you all the training for this from this material. So here I am taking for training purpose taking F1 footing having a length of 2200 mm and width of 2000 mm and depth of 550 mm and reinforcement detail of longer span T10 at 125 mm and T12 at 150 mm. This is the footing bar binding schedule tabular column, and from this I have extracted some cross section along the longer span and shorter span for your understanding purpose and created some formulas here for your understanding. Here this is the longer span cross section having a footing length of 2200 mm length into depth of 550 mm. Here we are having a reinforcement having with cover of 50 mm. The reinforcement will be placed like this in the longer span, and in the shorter span also same thing with a 50 mm cover and placing like this. So now this is the formulas to calculate the longer span rods and shorter span rods and bend allowance and longer span cutting length and shorter span cutting length and total length and density. So same formulas I am using to calculate the bar binding schedule in the Excel sheet. Just see these formulas, the same formulas I am going to feed in the Excel sheet. If anyone are interested to require these drawings, AutoCAD drawings and Excel sheets for their practice, just ping to the displayed number. I will share you these drawings and Excel sheets for your practice. Thank you. Requesting you people to practice this, then only these formulas will easily you can put it. When you are watching this video, just watch the video from beginning to the end and you will get understand. And at the time of practicing, just watch each and every formulas, and I will display those formulas also each and every stage. Study those formula, try to enter those formulas over there and practice it. Then it will be easy to do the formula. This is simple formula. When you are going to beams, when you are going to slabs, when you are going to columns, few more lengthy formulas will come. Then it will be easy to learn over in that time. So I am starting from serial number 1, and second item is description of items. Description means this is the footing number F1 and calculating bottom mat and top mat. And third column is number of items. Number of items means this is F1. How many number of F1 is there? That is the number of items. Here I am giving one number. And fourth column is dia of bar in mm. The bottom bar means it's a shorter span dia. So here what is the shorter span dia over here? This is the longer span dia 10 mm at 125 mm and shorter span is T12 at 150 mm. Shorter span is 12 mm dia and longer span is 10 mm dia. And bar shape I will explain you later at the actual classes. Then shorter span or longer span length in mm. So bottom bar means it's a shorter span. What is the shorter span length? Shorter span length is 2000, longer span length is 2200. 2000 and 2200. And what is the depth of the footing? Depth of the footing is 550 mm. 550 mm. 550 mm. And what is the clear cover for the footing? Cover for the footing is given as 50 mm. It is 50 mm. It is given in the drawing. Then spacing. What is the bottom mat? Shorter span spacing and longer span spacing. Shorter span spacing is 150 mm and longer span spacing is 125 mm. 150 mm and 125 mm. Then number of bends. How many number of bends are there in this steel reinforcement? So one number of bend and two number of bend, and here also one number of bend, two number of bend, each one having two number of bends. And what is the angle of bend? It is 90 degree. And then what is the anchorage length? Anchorage length means this is the anchorage length LD. So here LD is given as 300 mm. If it is not given, you have to take as per IS standard. It is 300 mm. This anchorage length on both side means it should be 2 into 300. So it will be 600. This is also is equal to 2 into 300. So total 600 mm. So only this much is the data to be entered from the drawing to the Excel. So rest all will calculate Excel. For that we need to insert all these formulas. If you add all these formulas over here, then this Excel sheet will calculate automatically. Then what is the number of bar? Then number of bar is equal to length divided by spacing plus 1. Length means this is the length, put bracket, this is the length. Okay, number of while calculating the number of bar, this is the actual length of the footing. Length will come for the longer span. This is the length minus 2 times of cover. So this is the cover, 2 multiplied by 2 times of cover, 2 multiplied by this cover, and close this bracket and divided by spacing. What is the spacing for this reinforcement? 150 mm plus 1. This is the total number of rods. Total number of rods in the shorter span. If any decimal comes here, we need to put round off. I will show you how to put that one. Again, I am calculating in the longer span. This longer span is equal to, open the bracket, for the longer span we need to take the shorter span length. Shorter span length minus 2 times of cover, 2 times of cover divided by spacing. What is the spacing? 125 mm plus 1. This is the shorter span spacing. Here you see the number of bars are coming in the decimal. So when you are calculating the total weight, this decimal will not useful. We have to take it round off. For that round off, we have to go to this formula cell and put round up. One command is there, RUNDUF. Round up command is there. You put one bracket and come to the end of this formula, put comma and make it at 0 decimal. So put close bracket and enter it. And the same formula to be entered it over here also. Here also this is equal to round up, open bracket, come to the end of this formula and put comma and close bracket. This is the round up formula. Then number of bars have been calculated. Then bend allowance. Bend allowance formula is equal to pi into d into angle divided by 180. Then for this is equal to, open bracket, pi value, write pi, pi, put one open bracket and one close bracket. Then it will take automatically pi value into d is equal to dia of the bar into angle. Angle is equal to 90 degree. Then close the bracket divided by 180. This is the bend allowance formula. It will take like this. So here how many bends are there? So 2 bends are there. That's why you have to put 2 numbers of bend. You have to take this number of bends. How much is there? 2. This 2 multiplied by this is number of bars. Then the 2 times of bend allowance has calculated. You see, in Excel again one more speed up work is there. Once you calculate the formulas over in this cell, again if the same formula is applicable for this line, again you no need to type over here the formula like that. Just select that cell and put Control D, the same formula will come down. Then cutting length. Cutting length is equal to length of footing minus LD minus length of footing plus LD minus 2 times of cover and 1 times of dia. So this I will put here. This is equal to length of the footing plus 2 times of LD, means we have already given 2 times of done 2 times of LD over here. That's why LD minus 2 times of cover, 2 into cover minus bend allowance. This is the cutting length. Cutting length coming in mm. The same formula I have to put it down, means again you select over here and put Control D. The same formula comes over here. Then total length is equal to, then total length has to be taken in meter. That's why this total length is equal to number of rods multiplied by cutting length divided by 1000. So then the total length comes in meter. Then put Control D for the below cells. Then unit weight. Unit weight is equal to D square divided by 162. This is equal to D. D means this cell. D into D divided by 162. This is the formula. So unit weight of this 12 mm came. Again put Control D. So this 10 mm density also came. And here is the important section over here. So whatever the total quantity of these rods, this 12 mm and 10 mm is there, no? This 12 mm rod quantity has to come in the 12 mm cell and 10 mm rod quantity has to come in the 10 mm cell. So every time you can't go and type it over here. This is equal to cutting length into density, and here is equal to this into this, like this. So and 12 mm has to come here and 10 mm has to come here. So every time you can't go and type it over here each and every cell. So if I am going, instead of 10 mm, if I am taking 12 mm, then result will goes, and the same 12 mm will not come in the 12 mm. That result is coming in the 10 mm. So that's why one conditional formula is there. That conditional formula has to be insert over here. Just listen carefully. I am explaining each cell how to put the formulas. Just listen carefully. Select this cell. We have one if conditional formula. If conditional formula, what will say? When the condition is true, it will get multiply. Otherwise, it will give the zero result. That is the if conditional formula. So this is equal to if open bracket means what is the condition? If logical test, what is the condition over here? If this cell, this dia is equal to this 8 mm is equal to this 8 mm, comma, then multiply with this total length and density of steel. Otherwise keep it 0. Okay, this is the equation over here. Just have a look. This is the conditional formula, only taking the dia of bar and total length and unit weight. This is calculating here, but here comes result 0. Why it is 0? Because this is not 8 mm, this is 12 mm. That's why here it has came 0. Don't worry. Then same go to 10 mm. Here also same equation. This is equal to if open bracket. What is the logical test? In this cell, this dia is equal to this 10 mm, comma, multiplied by this density of rod multiplied by this total weight, or else 0. Okay, here also came 0. Why? This is not 10 mm. That's why here also came 0. And go to this cell. Same formula. Put if open bracket. What is the condition? If this cell is equal to 12 mm. If this cell is equal to 12 mm. This is the 12 mm. Write 12 mm in words, comma, multiplied by this total length of rod into density, or else keep it 0. You see, here value is came because here it is 12 mm is there. That's why here value is came. Similarly, for the 16 mm, if this is equal to, if open bracket, this dia is equal to 16 mm, comma, multiplied by this total length in meter and into density, or else keep it 0. 16 mm. The same thing we need to put for 20 mm is equal to this. If this cell is equal to 20 mm multiplied by total length into density, comma, 0. And this cell is equal to, if this dia is equal to 25 mm, comma, multiplied by total length into density, or else, comma, 0. And this cell is equal to, if open bracket, this dia is equal to 32 mm, this dia is equal to 32 mm multiplied by this total length into density, comma, else 0. So you see, all the formulas are fitted over this line. The same formula if you want into this line, just select all this line and press Ctrl D, all the formulas will come down. You see, in this cell, this value come to the 10 mm dia. Why it has came to the 10 mm dia? Because here the dia of bar is 10 mm. If it is this 8 mm, it will come to 8 mm cell. If it is come 16 mm, it will goes to 16 mm cell. Similarly, if it is 32 mm, it will goes to 32 mm. So this is the logic we are using in the Excel to speed up the calculation. Dear friends, if you are like this video, kindly subscribe and share with your friends and colleagues. You will you will get immediately next videos. When I upload next videos, you will get the immediate notification.